right, in this particular lesson, we're going to be focusing on how to describe what's happening in a graph. What I would like you guys to do right now, in your graphing calculator, underneath the y1, I would like you to type in y equals x squared. You can type in x squared right here, and under the y2, I would like you to do parentheses, x plus 3, close parentheses squared, and then subtract a 1. So in your graphing calculator, I want you to type both of those in. We're going to take a look at those graphs. Okay. Now, there are going to be two things that are going to happen. I'm going to hit right here, I'm going to hit y equals x squared, and then I'm going to go open parentheses. It was x plus 3
close parentheses squared,
and then minus a 1. Now, the original graph, all right, it's going to be our blue graph. Our new graph is going to be our red graph. So we're going to look at it. Now, your calculator might look a little bit different than mine, so if you want to get your calculator looking exactly like mine, if you have my same version, I want you to hit the zoom button and the number 4 button. Hit zoom 4, that should give you these little squares. Now, some of you may not have the squares. You may not have your grid lines on. If you want to get your grid lines on, hit the second button and the zoom button and scroll over to here where it says grid line. And press enter, and you should have the grids. Okay? That's how you get your grid lines on for. Alright, so the graph went, what happened? It went, we go back to the graph, let's look at it. From here, it looks like it went down 1 unit and it went over 3 units, correct? All right, or you could say it went over 3 units and down 1 unit. Okay? But here's what I want you guys to put on your paper. All right? There's 2 rules that is happening. One of the rules is this. We went from f of x, and it became f of x plus a. And this rule deals with what's called a horizontal translation. We're dealing with something that's horizontally being translated. All right? So step 1, I want you guys to say it translated 3 units left. Okay? Because if you have right here, if it's x plus 3, it actually goes 3 units to the left. And remember what I told you guys yesterday. What number gets you back to 0? If you plug that in, what number gets you back to 0? Negative 3. That gets you back to 0. So that lets you know which direction you're going. Okay? So it translates 3 units left. Step 2. I'll change color too.
Is this the answer?
That's the first verbal description. That's one of them. Okay? The second part. We went from f of x to f of x plus a. Now, in this particular case, we didn't go up, we went down. So this was translated. I'll grab the translator, sorry. There's the D. It was translated 1 unit down. This right here doesn't deal with a horizontal translation, it deals with a vertical. Exactly. Translation. So I'm going to pause this real quick and I want you guys to look real carefully at where the A is located. This one's located on the inside of the parentheses. This A is located on the outside of the parentheses. So on the inside, you're dealing with a horizontal translation. On the outside, you're dealing with a vertical translation. All right. Right now, there are 2 things happening in this graph. I'm going to write down the 2 things that are happening, and then we're going to make a verbal description, and then we're going to check the graph. So before we looked at the graph and made a verbal description, now we're going to look at our rules, try to figure out the rules, and then we're going to check our graph and see if it actually happens. Okay? Here's the first thing that I see happening. I have f of x originally All right, and it looks like it becomes f of negative f of x. I'm going to highlight what I'm talking about. You guys see this negative sign right here? Okay, and that's on the outside. Okay, so that's on the outside. So I want you guys to look at your journal, and when you see something go from the original function to something where the negative's on the outside of a parentheses or an absolute value, tell me what you think is going to happen in the graph. No, it's not. There's not going to be translated. It's going to be reflected
over the x-axis?
across, yes, or over the x-axis. So this right here deals with reflecting across the x-axis. By the way, just to review real quick, if f of x becomes f of negative x, this is where you have, that's right, reflects across the y-axis. So this is kind of a little review right here. Now that's not the answer to this one, but if it's on the inside, it's across the y. If it's on the outside, it's across the x. That's the first thing that should happen. Okay? Second thing, all right? We have f of x, and it becomes f of a of x. I'm going to highlight it. Okay. Yesterday in our journal, we talked about where we're either multiplying or adding or subtracting. Okay? All right? So I want you to look at your journal. You should find this somewhere in your journal of where I said where f of x becomes f parentheses a times x. So look at that right now. Okay. In your notes, in your journal, you're going to do a quick little review. Okay? Whenever you guys have a problem, if I said y equals 2 times x, okay, or we'll say 2 times f of x, basically 2 times f of x, that's different than y equals f of 2 times x. This right here, where the factor is on the outside, is different from when the factor is on the inside. This is dealing with a vertical stretch, okay, or a compression. In this particular case, for your example, in this particular case, this would be technically dealing with a vertical stretch if you're multiplying it by a factor of 2. Okay? All right? Now, if this was 2x right here and it was on the inside, now you're not dealing with things vertical, you're dealing with things horizontal. This is a horizontal stretch or compression if it's on the inside. Or it could be a compression if it's on the inside. Now, in this one, the a value is equal to 2. If a is greater than 1, this is actually going to be what's known as a horizontal compression. Because if you multiply everything by 2, all those points are going to be moving away from the x-axis, not towards the x-axis. Okay, so this is going to be the part that might be confusing to start out with. That's why I want you guys to review. If the number right here is on the outside, you're dealing with something vertical. If this number is right here on the inside, you're dealing with something horizontal. Okay? All right, so I'm going to pause and I'm going to point up at the screen and make sure you guys understand what we're talking about. All right, so ours right here, this is going to be horizontally compressed by a factor of, now this is going to be confusing to start out with because this is the first time you've done it, okay? It's actually going to be horizontally compressed by a factor of 1/2 and not 2. Now what I'm going to do is I'm going to draw a picture to help go with this, okay? original function, all right, if you have the absolute value, kind of looks like that. If you look at it on the graphing calculator, that's what it will look like. All right. The new one, all right, will so if this right here is y equals the absolute value of x, this one right here would be y equals the absolute value of 2x. Do you guys see how I'm moving away? I'm moving away from. Yes.
When I graph that,
You have it. It's going to be reflected across. I know. I'm not talking about the reflection. I'm just talking about
Okay.
it moving away. You're right, but we haven't done the whole thing. Okay.
Okay.
This is just an example. This is just comparing these two. I know we have a negative version, so we're going to reflect it across. All right. So remember, we are compressing away from the x-axis. Okay? So compressing away from the x-axis, understand whenever you're dealing with a compression, it only works with a compression. Your factor will always be whatever 1 over your a value is. Okay? So our a value in this particular case was a 2. So our factor of compression will be 1 over a. This is a rule only for horizontal stretching or compressing. So this only works for horizontal. Vertical is easy. Vertical is the easiest one. The horizontal is where students usually get confused. Okay? So now on your graphing calculator, what I want you to do is hit y equals. We're going to clear out y1. We're going to clear out y2. And what we're going to do is we're going to hit alpha window enter to get our absolute value bars. Okay? And type in x. There's our original graph. Okay? Then I want you to go down and I want you to hit a negative sign, alpha window enter, and I want you to type in 2x. Alright? And then I want you to hit graph. Now I paused it, okay? If you hit enter, you can pause it as you're graphing it. Mine's pretty fast, so pause it. I didn't quite pause it as much as I wanted to. Alright? But understand, you see how these right here have been reflected across the x-axis.
Where's the pause button?
If you hit enter, you can pause it. Alright? So right here, it's reflected across the x-axis, and it's moved away from the x-axis. So it's compressing. It compresses horizontally. Those are two things. The two answers on your paper that you're going to put is it's reflected across the x-axis and it's horizontally compressed by a factor of a half. Okay. All right, we're going to continue to do some more, but I'm going to stop the recording for right now.